So far, we've discussed the idea of a centralized data warehouse as your default go-to option. But we've also introduced and discussed the idea of data marts, which are part of a multi-component data warehousing environment. So in other words, not centralized when you include data marts, but rather made up of multiple underlying data environments. For better or for worse, we have a far more complex process of selecting a data warehouse environment than simply centralized versus component oriented. This tree diagram shows all of the major alternatives at once, but let's decompose it and walk through the diagram a piece at a time. Our first choice, as we mentioned, is deciding if we want to aim for a centralized environment or alternatively go down the path of one that contains multiple components. If we decide on a centralized approach, we do have certain advantages by taking that particular path. That, again, should be your default option if at all possible. A centralized environment does give you that one-stop shopping that we said about building data warehouses for in the first place. And typically, especially for larger environments, you can take advantage of modern technology to make a centralized environment far more likely to succeed than earlier attempts back in the early days of data warehousing. At the same time, though, a centralized data warehouse requires a high degree of cross-organizational cooperation, which, as I pointed out a little bit ago, was not necessarily the easiest thing to come by, especially when you're dealing with data for analytics. It does require a very high degree of data governance, the maturity and rules that go along with our data. And also, there's a lot of ripple effects when you have a centralized environment. You make some small changes, and it typically will affect other portions of your overall environment. Or if you make changes in your source systems by adding, let's say, a new application, that could ripple into the entire data warehousing environment rather than just a single piece of it. At the same time, on the flip side of that decision, we have component-based approaches where if you kind of divide up your data into multiple components, decomposition sometimes does give you a lot of benefits in terms of isolating portions of the environment away from changes in other portions. You can, if it's desirable, use mix and match technology. As you incorporate new pieces, you can take advantage of new versions of databases or data environments, new business intelligence tools on top of the data warehousing environments, kind of a mix and match approach if indeed that's what you're after. If you do a component-based data warehousing correctly, you can essentially bolt together various components. Typically, it's not quite as easy as it might look on paper, but you do have that opportunity to take different pieces and get them to work together and integrate them that way. And also, you can overcome a lot of your organizational challenges that tend to compromise data warehousing by taking a sort of divide and conquer approach. But when you take a component-based approach, more often than not, you wind up with inconsistent data across those various components, and it's also difficult to cross-integrate the components with one another. The approach for the centralized environment, we have a couple different paths we can take there. One is if we throw an E in front of the data warehouse, we can think of an enterprise data warehouse as the default approach when we're building a centralized environment. So essentially what we're doing is building out a data warehouse that will satisfy the analytical needs of much or perhaps even all of our enterprise. At the same time, even though it's not quite a data warehouse, we did talk about data lakes as sort of next generation data warehouses. So you see a dashed line here rather than a solid line. Some people, some organizations, when they're approaching single centralized enterprise data warehousing environments today, rather than use relational database technology underneath, they'll go down the big data path and essentially build out data lakes. Now, within the EDW, even there you have a couple different choices. In addition to the relational databases that we commonly have used for data warehousing for a long time, for the last 15 or 20 years, we've also had specialized large-scale databases, columnar databases, and other things that are typically known as data warehousing appliances. So that's another underlying platform choice that we can go ahead and put to use if we're building out a centralized enterprise data warehouse. Conversely, on the data lake side, those specialized databases also fit into the data lake picture as well. Then you have other platforms that we can use, such as Hadoop or AWS S3 buckets or equivalent low-level storage technology. Now, let's switch over to the other side and look at our options for component-oriented data warehousing environments. And here, in general, we have two paths to take once we head down this path of component-based data warehousing, either an architected or a non-architected approach. Then, along the architected path, we either could put data warehouses and data marts together and have them interoperate with one another, or we can build an environment that is made up of data marts only. We've already taken a look at this classic dependent data mart architecture, which again resembles kind of the supplier to wholesaler to retailer paradigm. And we can see that dependent data marts are one form of that data warehouse plus data mart model. And you may run across a variation of the dependent data mart approach that's called the Corporate Information Factory, or CIF. The CIF model was originally proposed by Bill Inman, who's the same fellow who gave us our original 4 rules of data warehousing that we saw: integrated, subject-oriented, time-variant, and non-volatile. And the CIF is essentially a dependent data mart architecture, but with very specific rules for how the EDW component is architected and who is allowed to have access to which components. Now, CIFs aren't really used that much anymore, but you may run across that approach, and if so, it's easy enough to find information and details to build on what I've just briefly covered here. Another alternative that includes data warehouses and data marts together is what we might call a front-end data mart. So in a front-end data mart, instead of having the data marts behind the data warehouse, just like the name would apply with a front-end data mart, they exist in front. So if you had, for example, an SAP implementation that was for your North American operations and another SAP implementation for international operations outside of North America, you could essentially build a data mart, which is something other than a full-scale data warehouse, for each of those SAP implementations. And that's where the primary analytics and business intelligence will occur. But then some of the data, not necessarily all of the data, is sent out from each of those downstream into a data warehouse. So you essentially reverse the order of your data marts and your data warehouse with this front-end data mart approach. Now, if we jump over to the data mart only side of a component-based architected approach, we're going to find really just one major alternative here, and that's something called the data warehouse dimensional bus that was defined by Ralph Kimball, who was one of the pioneers of data warehousing. And in fact, much of the dimensional modeling content that we'll discuss later in the course comes from Mr. Kimball, just as the original data warehousing rules in the CIF model came from Bill Inman. The idea behind the data warehouse bus is that all of the data marts follow a principle that's known as conformed dimensions, which essentially means that we have an apples-to-apples view about our key subject areas, such as customers, products, employees, geographies, students, faculty, and many other subject areas across all of our data marts, even though they're built differently and also potentially even on different platforms. Achieving the idea of conformed dimensions is a somewhat difficult proposition, as anybody who's ever done any data warehousing will tell you. And recall that we discussed that the challenges to centralized data warehousing largely today are far more in the realm of interpersonal and interorganizational conflicting priorities than they are with regards to technology and the body of knowledge. So this takes us to our final option, which we sometimes will call a federated data warehouse or a federated collection of data marts. In this approach, we essentially agree to disagree about the business rules, the data models and structures, and pretty much everything that would be required to build either a centralized data warehouse or that data warehouse bus approach. So instead, what we do is build a collection of independent data marts, as we've seen already, and essentially draw a dotted line around those independent data marts and just sort of declare, hey, we're going to consider all of you data marts to be part of a data warehouse, even though we are likely to have different answers to the same queries and reports coming out of those multiple data marts. You should think of, especially nowadays, this independent data mart or federated data warehousing approach really only as a last resort as you embark on data warehousing. It was a popular approach in the latter part of the 1990s after that first generation of data warehousing ran into so many significant challenges. Practitioners of the day, including me, often fell back to the smaller scale environments that had little or no integration under the premise of, hey, it's better to have a partial solution than no solution. Today, though, with data lakes and superior relational technology and all the other tools that we have to work with, not to mention our vast body of knowledge and practices for data warehousing, this idea of a federated data warehouse should really only be used as a last resort. You don't really want a proliferation of data marts all over the place. And so there you have it, plenty of options to choose from. And this is where data warehousing is definitely every bit as much of an art as it is a science. We do have some guidelines to go on, such as your default choice should be a centralized approach, but this is where experience and that sort of grounded in reality nature of each individual organization comes into play as these choices are made.